Welcome to Module 01 of our Ultimate Computer Programming course. In this explainer, we're breaking down the absolute basics of coding for absolute beginners with literally zero prior experience. Whether you want to get into software development, cybersecurity, Linux, or AI engineering, this foundational course is the absolute perfect starting point for your tech journey. So let's just get right into it. Okay, we've got to start with the ultimate question. How do these essentially dumb machines actually translate human logic into the massive, complex digital world we see all around us? Think about it. How does a simple piece of metal and plastic know exactly what to do when you swipe a screen or click a mouse? It's kind of wild, right? Here's what we're covering today. First, an introduction to what exactly computer programming is. Then, we'll look at how computers understand code, specifically source code versus binary, and the role of compilers and interpreters. After that, we'll hit some real-world examples like apps, websites, and AI automation, before wrapping up with why you absolutely must learn to code in 2026. All right, Section 1. What exactly is computer programming? Simply put, programming is really just the process of giving machines a specific set of instructions that describe exactly how a task should be carried out. You see, a device can't figure out how to solve a problem on its own. It needs a developer, someone like you, to analyze the situation and write explicit instructions using a specific syntax. It's basically a rigid set of rules for that device to execute. And here is why this is absolutely crucial. Code literally runs our everyday lives. I mean, every single time you open a mobile app, browse the web, or even just turn on your smart TV, you're relying entirely on code written by a software developer. It is the invisible architecture running our modern world. Moving on to Section 2, how do computers actually read this code? So there's actually a massive divide between human logic and machine processing. We humans write in what's called a high-level language. This is basically readable source code using everyday English keywords like print or if. But the computers, they don't speak English. They only understand a low-level language, which is pure binary machine code, just a massive wall of zeros and ones. So how exactly do we cross that gap? Well, to bridge that gap between our human logic and the machine's execution, developers use something called a compiler. Think of a compiler as a highly specialized translator software. It takes our human-readable source code and converts it straight into those machine language instructions. And fun fact, this groundbreaking concept was actually pioneered by the legendary American computer scientist Grace Hopper back in the early 1950s. Now, when we look at how different languages run, there are two main methods. First, we have compiled languages, like C and C++, which are translated entirely into machine code before they ever run. Boom, done, all at once. On the flip side, we have interpreted languages, like JavaScript or Python. These are actually read and executed line by line on the fly by a totally different program called an interpreter. Pretty neat, right? All right, on to Section 3, the languages of code. Time to choose your tool. You've probably noticed that different languages serve entirely different purposes. For instance, Python is incredibly popular right now for data science and AI, mostly because it's super readable. Then you've got JavaScript, which is the undisputed king of web development. If you're looking to build high-performance systems or cutting-edge games, you'll definitely want to look at C++. And of course, Java remains a total powerhouse for enterprise applications and Android mobile apps. But here's the really crucial takeaway. No matter which language you choose to start with, they literally all share the exact same foundational concepts. You're always going to use variables to store your data, operators to do the math, and control statements like loops and conditionals to make decisions and keep yourself from typing the same thing over and over. Seriously, once you learn these core building blocks in one language, picking up the next one is a total breeze. Let's jump into Section 4, real-world applications. Let's see this programming in action. The real-world applications here are truly endless. Sure, front-end web development and iOS mobile apps are massive, multi-billion-dollar industries, but coding goes way beyond that. We're talking about powering insanely complex physics simulations, running bioinformatics to analyze DNA, navigating self-driving autonomous vehicles, and of course, driving the massive recent boom we're seeing in AI automation. To put that into perspective, just look at the impact of programming in pharmacology right now. Christy Carpenter over at MIT pointed out that AI automation is being actively used to compute crazy combinations of compounds, which helps discover new affordable drugs way faster than before. Think about that for a second. Your code literally has the power to save lives. How cool is that? Section 5, the programmer's mindset. Let's talk about the skills you need for success. Now, beyond just memorizing the syntax, successful developers really have to cultivate a specific set of soft skills. You need an intense curiosity and, honestly, immense patience for debugging errors, because trust me, you are going to encounter a ton of bugs. That's just a given. You also need the resilience to just keep trying and really strong communication skills. Despite the old lone wolf stereotype, programming is a highly collaborative field. You'll be working closely with teams and constantly taking feedback.
Finally, Section 6, your coding roadmap. Here is exactly why you absolutely must learn to code in 2026 and exactly how to get started.
So, here is your step-by-step journey mapped out. Step 1, figure out your purpose. Are you building games or analyzing data? Step 2, choose a language that matches that goal. Step 3, install an integrated development environment, or IDE, like Visual Studio Code. Step 4, practice those fundamentals every single day. Step 5, start building your own projects from scratch. And lastly, Step 6, join a developer community. You definitely don't want to learn in isolation. Now, when you hit Step 5 and start building projects, you really want to focus on creating a solid portfolio. Try spinning up a fully functional e-commerce site with a working shopping cart, or maybe a mini social media feed, a job board app, or even a resume builder. Using popular frameworks like React or Node.js to build these out is a surefire way to make your resume completely stand out to employers. And hey, once you're feeling confident with that portfolio, you can seriously accelerate your learning by contributing to open source software. If you don't know, this is software where the original source code is made freely available for literally anyone to inspect, modify, and enhance. Finding mentors and actually pushing your code to open source projects on platforms like GitHub is an incredible way to level up your skills in the real world. Of course, this foundational explainer is really just the beginning of your journey. So be sure to subscribe to Crypto Raviya for more premium explainers on programming, Linux, cybersecurity, and tech frameworks. We have covered a ton of ground today, all the way from binary zeros and ones to the vast, life-saving applications of AI. So I want to leave you with one final, provocative question to think about. With all these incredible, powerful tools right at your fingertips, what world-changing idea are you going to bring to life with your very first line of code?